In this video, we're going to be studying frequency dividers. As you can see on my screen, I have a D flip-flop that is connected to always toggle. The top and bottom override, set, and reset. I didn't want to deal with those for this lesson, so I just connected them to ground always or to 0, so they're never going to be active. So here, as you can see, I have my clock. In this case, I have it set in 5 hertz. My computer, I guess 5 hertz, it's whatever the computer recognizes as 5 hertz. So it's about you can see it blinking on and off here. So what I want you to notice here is that if my flip-flop is always set to toggle, the output frequency is half of the input frequency of the clock, because the output only changes on the rising edge. In this case, the output is going to toggle every other cycle of the clock. As you can see, it's very obvious that the green signal coming from my clock is toggling on and off, and the output Q in the pink signal is toggling on and off half as fast. Now, if I were to then take, let me see if I can do this. If I were to take and make a copy of this flip-flop connection, I'm going to also ground because I don't want these overrides to take over. If I were to make a copy of that one, and actually Control Z, okay, I'm going to copy the entire thing so that I don't have to worry about that. Like, there you go. I have made the whole copy right there. I have another probe that's going to show up in blue. And this clock now comes from the previous flip-flop right here. Notice it's going to, let's plot what happens. And since the input frequency of the clock gets halved coming out, I want you to notice that the frequency of this second Q over here in blue, it's going to be half of the pink one. So the original clock frequency becomes divided in 2 or halved. And then this one becomes divided into again or halved. So what we have here is the original frequency is going to be divided by 4, as that's shown on the blue signal. And we can keep adding flip-flops. If I do the same, copy this whole thing again and duplicate it, I can add a third flip-flop. Oh, this is kind of too close to blue. Let me change the color to something obviously different. I guess let me make it yellow, orange is fine. So let me press play, and you're going to see now that the frequency gets divided even further. Here it's running, see how the simulation is running a little slower because we have more items on our simulation page. So they're all the green. Every time the rising edge happens on the green, the pink toggles. Every time the pink gives a rising edge or a 0 to 1 transition, the blue toggles. And every time the blue goes from 0 to 1 or the rising edge, the orange toggles. And this repeats over and over and over. As you can see, the frequency gets divided in half each time it goes through a flip-flop set to always just toggle. This can also be achieved identically with a JK flip-flop that has been set to always just toggle to connect the power to J and K. So that is this is what is called a frequency divider. No matter what the frequency is, let me actually change this to so we can see a little bit faster. Let me change it to 100 hertz. Okay, if I press play now, you're going to, let me zoom in a little bit because it's a little too tight. There you go. So as you can see, my input clock shown in green is 100 hertz. Based on that, my first output Q in pink would be half of that, which would be 50 hertz, 50 hertz. The second output in blue would be 25 hertz. And the third output in orange would be 12.5 hertz. What we have just made is a circuit that divides not, this is the original, this is divide by 2, the blue would be a divide by 4, and the orange would be a divide by 8. circuit. So this is how a frequency divider works. And again, you could do it with a D flip-flop or a JK flip-flop, as long as there are any flip. Actually, there's other flip-flops. There's a T flip-flop, SR flip-flop. No matter what flip-flop, as long as you have it set to only toggle and the overrides are not active, it's going to be a frequency divider. Every flip-flop divides by 2. 2, 4, 8, 16, 32, etc. All right, so that is a frequency divider.